Okay. All right, so what you have to do to find vertical asymptotes is set the denominator to 0. It's the exact same thing as restrictions, exact. So you would factor this as x minus 6, x plus 1 equals 0. So we have two asymptotes. We have one at x equals a -1, and we have another one at x equals 6. Okay? Questions right there. All right. Vertical asymptotes are a lot easier to find than horizontal. Horizontal are not hard. You just have to remember the process. Okay? Now, I'm going to save you guys a little bit of time for horizontal. Okay? On a piece of paper, or if you can spit it up here or somewhere, I have mine on my, I'll talk about what this means in just a minute, okay? So, write these down. Okay? What this means is we are going to compare, in order to find horizontal asymptotes, we're going to compare the degrees of the numerator to the denominator, okay? So that's what compare degrees means. So if you need to add a little bit more to it or something, that's fine, but we will be talking about this the whole time. So you should know it by the end, okay? NUM stands for numerator, okay? So I'll let you write that down and then I'll talk about it. Take another minute to do that. Just sucks when the coffee runs out. So depressing. I'm trying to be good. I'm not drinking my coffee in the morning because I have just a little bit of coffee with a lot of cream and sugar. So, and I got my blood drawn a couple weeks ago and they say I'm pre-diabetic, which means I have to cut down on my sugar and carbs. Those are the two things I like the best. So this is not too bad for me. So I still get it. But I used to get this and have my coffee in the morning. So, it's depressing when this is over with now. All right. So what we're going to do is we're going to find the degree of our numerator, we're going to find the degree of our denominator, and then we're going to compare them. You got three scenarios. The numerator degree can be less than the denominator degree. If that's the case, we are going to have a horizontal asymptote at y equals 0. Then, if they are equal, if the degrees are equal, numerator degree is equal to the denominator, then what you do is it's going to be, you take the leading coefficient of the numerator and put it over the leading coefficient of the denominator. That's what LC means, leading coefficient. Okay. And then the third way is the numerator degree is greater than the denominator degree. And in that case, there is no horizontal asymptote. Lucky for you, not on 1710, but lucky for you, you're done. On 1710, what happens is when it doesn't have a horizontal, it has a slant asymptote, and they have to find that asymptote, but you guys are lucky you don't have it. So you should win. Okay. It's not that it's hard, but they never get to that part. They get to this part, they know these two rules, then they get here and go, I don't know what to do. So it's because they don't study. All right, so let's do this. And I'm gonna be, and this is what I did. Guys, we didn't have pre-calculus back in the 80s. We had algebra 2, trig, and then you went to calculus, okay? We didn't have this in classes called pre-calculus. So I hadn't done this since like 81, 82, I graduated in 83, so that tells you how old I am, okay? So when I started teaching 1710, I was like, what the crap? Oh my gosh. They started giving me, when I'm looking, preparing for class, because now I don't have to prepare for class, not these classes. The only one I have to prepare for is 1720 because I don't teach it all the time. But it had all these words, and I'm like, oh my God. And then I'd start working problems, and I always had to keep flipping my paper to go back and forth. This is when you save the flipping paper. Okay. And I had to come up with something that worked for me. So I put it on a little post-it note, just like I don't need this post-it note. I just did it to show you guys. Okay. So this way we don't have to flip it back and forth. So here's what we're going to do. We're going to compare the numerator degree with the denominator degree. And I'm going to write this down for these examples, just because, again, when I was learning it, this is what worked for me. Okay. I didn't have to do notes. Okay. I didn't just put answers, because if I just put answers, that was too easy. Okay. So here's what we're going to do. Now, this one here, some of you are going to probably miss this degree because you don't deal with that much. But this, what is the degree on the denominator? The degree is the highest exponent on x. So this has a 1. So it has a degree of 1. Remember, that's how we find degrees. If it's at x to the 5th power, that would be 5. You know, the stuff from chapter homework 13. Remember when we had to find the degrees here? Okay, that's the same thing. We're not doing anything different. That's why we have to talk about degrees a lot, because we use them in things. Okay, well, if this has a degree of 1, oh yeah, sorry. If this has a degree of 1, what does this have a degree of? 0, good. Now, let me explain why. Because when you have 3, it's really 3x to the 0, but anything we learned a long time ago, anything to the 0 power is 1. So this is the same thing as saying 3 times 1, which is 3. Okay? So you need to know that because you'll see it in your homework. Okay, so this tells me that the degree of the numerator is less than the degree of the denominator. So this is where you go to your handy dandy notes over here, or wherever it is on your paper. If that's the case, where's my horizontal asymptote? Y equals 0, okay? All right, let's go to this next one. This has a degree of what? 1, good. And this one has a degree of 1, right? Okay, so these two are equal. So I'm going to write numerator degree is equal to denominator degree. And I just shorten it because I don't want to write all those words out. I barely want to write this out, but I want you all to know what's going on. Okay, so I do. So I come over here and I look at my handy dandy notes. They're equal. This is the second scenario. So I'm going to take the leading coefficient of my numerator and put it over the leading coefficient of my denominator. Now I might do this just so the more I write it, the more I learn it. Now, you guys have to know what the leading coefficient is, but we've already dealt with that. We dealt with it in homework 14. It's the same thing. This was a -1. The leading coefficient here was 3. So the leading coefficient right here of x is 1. the leading coefficient down here, there we go, is -2. So we now have a horizontal asymptote at -1/2. Not hard. You just have to remember the 3 scenarios, okay? And what to do when that happens. Find your degrees first. What are both of them? Degree of what? They both have a degree of 2. That means the numerator degree is equal to the denominator degree. So you go to your handy dandy notes. What do we do when they're equal? Leading coefficient of numerator over the leading coefficient of the denominator. So y equals this. And again, I wrote it. Guys, I'm telling you, I had to work problems when I was first learning this so that I knew what to do and what to tell my students when I got up here. It just doesn't happen. No, I think I told you, I don't know if I told this class or not. When you go through school, nobody teaches you how to teach. You got to come up with it on your own. So I listen to my students all the time and learn stuff from you all. Just as, well, maybe not as much as you learn from me, hopefully. But I do pick up on things and I know what it's like to sit in your place. I just do. But anyway. Okay, so the leading coefficient in my numerator here is a 2. My leading coefficient down here is a 1. So I now have a horizontal asymptote at y equals 2. Okay. Right here. This one right here. By the way, you will see one of these, I believe, in one of your quizzes when you take this, okay? Remember, right here, because you're squaring it, this doesn't have any restrictions down here. So that's why there's no vertical asymptotes, okay? I just know because somebody asked me this question the class before you all. And remember, it can't be well, no matter what, if you solve this, you'd end up with a square root of a -1, and you can't take the square root of a negative number, so it's nothing. And it won't factor. So if you thought it was 1, if you square 1, you get 1. That's going to give me 2. If you square -1, it's going to give me 1. 1 plus 1 is 2. So there's no restrictions here, so there's no vertical asymptotes. Now, however, let's see if there's a horizontal one. Again, we take the numerator degree and compare it to the denominator degree. Well, degree of 1, right? Degree of 2, right? So when that's the case, it's less than, right? Numerator degree is less than the denominator. And that's the case. You read that. You have a horizontal asymptote at y equals 0. This isn't hard. You just have to remember to compare your degrees and what to do when it's less than, equal to, or greater than. Right here, this one right here, what do we know about the numerator degree compared to the denominator degree? What is it? It's greater than now. Okay? When it's greater than, what happens? There is none, right? You know how I know that? I'm looking at my handy dandy notes right here. Okay, numerator degree is greater than denominator degree. That means there's no horizontal asymptote. So I am just going to abbreviate no horizontal asymptote. HA. Okay, you want to spell it out, spell it. Okay. And this last one, see if you can find it. Okay. What'd you end up with? 1. Good. Okay. They're equal, so you put the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 1. 1 over 1 gives us 1. All right, questions? All right, we are going to now, we learned all these shortcuts. Remember the x-intercept, y-intercept, all that good stuff. We're going to learn how to put it all together to graph without a calculator. Okay, without a calculator. Okay, so here's what we're going to do. When you tell me to graph this, okay, they just say graph the rationals. Okay, they do say to graph the function. Okay. When you tell me to graph something like this, first thing I'm going to do is find my asymptotes. I'm going to find my vertical asymptote first. Where does that come from? Denominator. That's something I didn't do up here. Vertical comes from my denominator. Okay. I just do this so that it tells me where it comes from if I was using these notes when I go to do my homework. Okay. So my vertical comes from my denominator, meaning what are my restrictions? Okay. What's my x going to equal? If I solve this, what am I going to get? 2. I would subtract 2 and divide by -1, and I get x equals 2. Okay. I'm not going to teach you how to solve this equation because you should know how to do it. Okay. All right. So that means we've got, and I'm going to show you how I can do this neatly without help of my license and all this. It actually is easier to see if I don't use it because I darken this line a little bit. Okay, I have this horizontal asymptote at x. I'm sorry, my vertical asymptote at x equals 2. Okay, that didn't take but a second, right? Now, my horizontal asymptote. I compare my degrees, right? Just like I did before. This has a degree of 0. This has a degree of 1. So my numerator degree is less than my denominator degree, which means where is my horizontal asymptote? Numerator degree is less than denominator degree. Where is my horizontal asymptote? 0. One of those days, I guess I got to just tell you the answers. Okay, so right here, but thank you for the 2 that have answered. Here is my horizontal asymptote at y equals 0. Okay. Questions on those 2? Other points that we need to know how to do are x-intercepts and y-intercepts. Okay. So what do we know about all x-intercepts? What's true of all x-intercepts? Y is equal to 0. Very good. Okay. Well, watch what happens when I do this. Okay. So I'm going to plug in 0 for my y right here. Okay. And I'm going to set that equal to -1 over -x plus 2. Now at this point, I would cross multiply and I would get 0 is equal to -1. Does that even make sense? No. So there is no x-intercept. Okay. Besides, we have an asymptote on the x-axis, right? You didn't even have to do that work if you'd recognize that. In this case, sometimes you'll have one. If the graph looks like this, you'll still have one, but you have to have 2 or more vertical asymptotes. Now, the other way, but how I taught you to get rid of your denominator is to multiply both sides by that denominator. That cancels out. I get -1. Over here, I get 0, so it didn't really matter. Okay. All right. Now, just because we don't have an x-intercept doesn't mean that you don't have a y-intercept. Okay. You always will have a y-intercept. So what do we know about all y-intercepts? That x is equal to 0. Very good. Okay. So wherever I see x, I'm going to put 0 in there. So I have -0 plus 2, which that doesn't even make sense. Okay, but I get y equals a -1 on the top, a 2 on the bottom. I have -1/2. Okay. All right, let's graph that point. 0, -1/2. It's about right here. Now I know all of these graphs are going to look like these things. They're going to be funky graphs now. They're not, they're going to be broken. I know that because of asymptotes. Okay. So the only way this graph down here can do this is to come, it's going to approach that asymptote, but never cross it. And it's also going to approach this horizontal one, but not cross it. And I know that just from here, just from that one little point. Okay, we still have another part to this graph. That's the left-hand side of that vertical asymptote. Well, we need something over here on the right-hand side. But the question is it going to go here or is it going to go here? Sometimes they'll go here, sometimes they'll go here. There's an easy way to figure it out. Give me an x value to the right of that asymptote. Give me a number from 3 to infinity. Give me a number. What? 5? Would you pick? 3? Doesn't really matter. You don't want a huge number if it's not on the graph. Okay? I can explain it, but it's just too hard. I'm going to pick 3, but 6 would have worked as well. It wouldn't matter, okay? Because it's going to give you a positive number. All right, so if I pick 3, all I do is take that 3 and substitute it in here. Remember table of values where you picked a bunch of x's and you plug it in? That's all we're doing. So I would get -1. Oops. I'm plugging it into here, okay? I'm plugging it into right there. I'm just going to take it down here. -1 over, when I plug in a 3, it becomes a -3 because of my function. So I get -1 over -1, which gives me a +1. Okay? Now somebody picked 6. I think, Thomas, you picked 6. Or 5, okay. You picked 5. You would have gotten -1 over -5 plus 2, which give us a +1/3. Okay. Either way, if this point here, 3, 1, go ahead and graph that. You go right 3 up 1. It's right there. I know that that curve's going to be up here because it can't cross these asymptotes, right? Now, Thomas picked 5. Well, he got one. We would have gotten 1/3 had we used that. So go over 5, a third. It's still up there, right? Doesn't really matter. So now all you do is draw your curve. It approaches our vertical one, doesn't touch it. Okay, and you're done. Now, yes, your calculator will graph this for you. Okay. But you're going to spend as much time trying to figure out what points to graph. The other thing is those of you that only learn your calculator, this is the crap I'll get. And I call it crap because this is what they'll give me. They'll go like this. Well, that's great. I don't see an x-intercept. I do not see a vertical asymptote. I don't see a horizontal asymptote. I don't see a y-intercept. This is a big fat boom. Okay, it's wrong. Look how nice and neat this is. I didn't use a straight edge. I slowed my pace down. Just slow down, okay? All right, let's go over here. Find your vertical asymptote. What is it? -1. That was fast, right? You'd still be looking for your fraction key on your, you'd still be turning your calculator on. Okay, we got a vertical asymptote. We still got to draw it in, so that can't take up the time. Okay. Horizontal, we have to compare our degrees, right? They're equal. They both have a degree of 1. So you'd put the leading coefficient over the leading coefficient. So you're going to have y equals 2 over 1, which is 2. Well, we have this here. Y equals 2, right? Pretty easy. That one took what? 30 seconds, is that? Not even? All right. The two other things that I think are important are x and y intercepts. Well, we know how to find the x-intercept. You plug 0 in for y. Because I need a value at x. Pretty much how it goes. All right. So I have 0 equals 2x minus 4 over my x plus 1. Guys, the shortcut to this is just set it equal to the numerator. Because watch what happens. You can cross multiply if you want. That's how I do it. But if you do it the way I taught it, you multiply by the least common denominator. You do that there. You do this here. Notice you end up 0 equals the numerator. Now you solve this equation. You add 4 to both sides, divide by 2, and you get x is equal to 2. Okay. How did I get 2? I added 4 to the other side and got a positive 4, then I divided by 2. So I have an x-intercept at 2, 0. That is right here. I already can tell you which way that's going to go, but I got lucky in my first class, but don't do it yet because we need to find our y-intercept. We need a number in the y value. So our number in our x value is going to be 0. So you plug 0 in for x up here. 2 times 0 minus 4 gives us a -4 on the top. Then you have 0 plus 1 on the bottom. You get 1. So we have a y-intercept of -4. Now I know this curve goes like this. Remember, it approaches those asymptotes but doesn't touch them. When you graph this on your calculator, it is going to look as if it touches it. And that's because the pixels are too big in the calculator. You can't tell that they don't. Okay, that's the other way I'll know that people only know how to use their calculator. Okay, now the only thing is we know there's another part to this graph. There's rather a part here or there's a part here. Well, pick a value over here. -4. Okay, so let's plug in -4 and see what happens with our y. Well, you say 2 times -4 gives us -8, right? -4 gives us -12 on the top. On the bottom, I have -4 plus 1, which gives me -3. So I get a +4. So this is the point, -4, 4. So now go graph it. Left 4, up 4, right here. And now I know that this is going to curve up towards that and down towards this one. And there you have it. Now, some of you are going to say, oh, well, it's always diagonal from each other. If this is the graph here, it's got to be here. No. Because this one was the same way. There's no guarantees, none. These are funky graphs, no matter how you look at it. There's no rhyme or reason to them. It depends on what this looks like right here, okay? So make sure that you actually test it, okay? You know how I said your calculator's going to lie to you? If you were to do this on your calculator, let's say this one here, 2x minus 4 on the top and x plus 1 on the bottom, and you hit graph, mine's in zoom 6, okay? You will see this, right? Well, I should have done the other one. Remember we have a horizontal asymptote at 2. You can actually put the horizontal ones in there. But notice what this looks like, but there's no x-intercepts, no y-intercepts, no asymptotes, okay? And then if you wanted to put in the y equals 0 or y equals 2 in this case, there it is. This one's a pretty good graph. The calculator's not lying to you. But if I use this one instead, let's see if I can get this. 1 on the top, negative x plus 2 on the bottom. Watch what happens when I graph this.
You put up minus on top.
Let's try this again then. It was what? Oh, negative 1. Yeah, thank you. And this was at 0, right? So I need to change that too. Okay, now let's graph this. Thank you. See how it looks like it's on that y-axis? I mean the x-axis? That's because the pixels are too big. Okay? The calculator's not perfect. You just need to know that this is actually not touching that. And this one is not touching this one here. It does not touch that. It's just so close that you can't see. All right. When you get way out to like 100, all right, that decimal would be so small that you wouldn't see the difference between 0 and that on a calculator. Okay. So, all right, that finishes up that. Now you need your calculators out. Up until now, they've given you the functions, okay? And you know, I've always been like, does anybody need one of these, by the way? Everybody have one? Do you have an extra one back there in the back? Can you pass it down? Thank you. Okay. Up until now, they've given you the function, and I've said you don't have to come up with the function. You just have to use the function. Know what X is, know what Y is, or know what T is and H is T that they stand for, okay? Well, guess what? We're now going to find the function. But your calculator is going to do all the work for you. The only thing you have to learn is how to use your calculator on this. There definitely will be one of these on your test this time, and there'll definitely be one on the final. So do you think you need to know the steps? Yes. Yeah. Yeah, I got one up here. Okay. Now it goes by and it tells you step by step on what to do. All right. It's not hard. Again, you have to remember the steps. You can't come up to me during the test and go, hey, what am I supposed to hit? How do I get to whatever? And by the way, this is the long way, but you see this catalog? That gives you every single button that this calculator will do. You don't want to do it because here's what you have to do. If you hit that second button, see how it lists everything that it does? That's just the A's. Now we get to the B's. Now we get to the C's, okay? That's not the way to do it if you can learn, okay? Now, here's kind of how I think about this. Some of you may have already taken this class. There's a class here that they take information from surveys and stuff, and they make the lines or the formulas or they do stuff with it. What's that class called, you think? Stats. Okay, statistics, okay? Look at your calculator and find the stat button, okay? All right, so what you're going to do is this button right here, it is 2 over from your alphabet. You're going to hit stat. And now we are going to edit our lists. We've got to put our X and our Y's in here. And that's under edit. So at this point, I can rather hit 1 or I can hit enter because it's highlighted either way. And it goes to this. Mine already has the values in there because I've already taught this, okay? Does anybody else have values under their L1 and L2? Okay, so here's what we're gonna do, because I'm gonna clear it, and we'll have to do this for our second problem, okay? Watch how I do this. Everybody look, because we're not in any hurry, okay? We're gonna go up to L2. I'm gonna highlight it. I'm going to hit clear, and I have to hit enter. That clears out that list. Then I'm going to go over to L1. I'm going to go up and highlight L1, hit clear, and hit enter. Okay, now it's clear. All right, you see all our X values? You're going to put that under L1. You're going to hit 0, hit enter to drop it down. You're going to hit 1, you're going to hit enter. 2, 3, 4, 5, 6, 7, 8. Now, the only thing you want to do, because here's what's going to happen. Some of you know exactly what to do, but your fingers get in the way and you miss a decimal point, or you miss a number, you type in the number wrong, and it's going to throw everything off. Okay? Or you're going to get an error message. An error message happens when you have, see, this is on L110. That means this is in list of this under L1. This is going to be your 10th thing. Okay, so we have 9 of these, right? You need 9 matching. You need for every X, you need 1 Y. Okay, if you end up with 8 or maybe 11 of these, it's going to give you an error message because you don't have a matching L1 with a matching L2, because that happens. Okay, hit your right arrow key, go under L2, and you're going to put in 0.5 next to 0. Okay, hit enter. There's my first point. Now you're going to put in 1.3, 2.9, 2.4, 4, 5, 5.4, 7.7, and 8.3. Now, notice what I ended on. It says L210. So I know it matches. The only thing I might want to check for, and we're all working together, so you're going to know whether you typed it in right or wrong. I will say this, last class, I had a kid whose his were exactly right, but he gave a totally different answer. But I was able to fix it. We reset his calculator, and now he gets the same answer as we did. So that's part of the problem. If you don't bring the calculator, and when you go to use it during the test, I can't guarantee you whether it's set right or not. Okay. So, all right. So we have, the only thing I'm going to tell you is if you were taking your test or doing this on your homework, let's say, and you get it wrong, first thing you need to do is check to make sure all these numbers match and all these numbers match. So those are the two, that's the biggest mistake. All right, now you see what we just did? That was step 1 right here. You enter the data into set editor. That means we hit stat, and then you can hit 1 or you can hit enter because it's stat edit, okay? With X values under L1, Y values under L2. In the stat menu, okay, what does that mean? That means hit stat again. And we want it to calculate. So we're going to go over to calc. Now, what we are doing is we are creating a linear model using regression. So we are going to hit number 4 and watch what happens. it looks like this. Is our X under L1? Our X value is under L1? Yeah. So we're gonna hit enter. Our Y values under L2? Yeah, so that's good. Now I don't know what frequency, I don't know. Go down to calculate. And now you hit enter. This is our Y equals MX plus B, but they use A instead of M, okay? So it says oh, I still have my other one up here. It says use 3 decimal places, okay? So our Y equals MX plus B, and in this case, it's AX plus B. Our A is 0.967. X plus, because this is a positive 0.3. You just saw the equation of the best fits. Okay, that's what we're finding. You've got, see how this kind of goes up? You got a line in the middle of that. Okay, somewhere in the middle of these. And that's a line of best fit. It's not exact, but it's close. So now that we have this, if I wanted to know when X is 12, what's Y, you just take 12 and plug it in. Yes.
That line also the average of the.
Pretty much. That's pretty much what it does. Yes. You can think, that's how I think of it. This is kind of the average of the data. Anybody's calculator not come up with those numbers? Anybody? Because I thought that was really weird in last class, but he happened to come in after class to ask me about that. Okay, so everybody looks good? Okay, and by the way, look right here. When I hit stat and go over to calculate, we have linear regression, which means a line. But look what else, we have quadratic regression. And I think there may be, that must just be that one. We got quadratic and cubic, okay? Now, we aren't gonna have to worry about that. We might do quadratic, maybe, but it won't be until Friday. Okay. Now, the following table gives the wind speeds, Y in miles per hour of a hurricane versus the barometric pressure X in whatever MB stands for, I don't know. Use the data in the table to find the least squares regression. That's what we're talking about. It's the same directions up here, but be careful. Pay attention to your instructions because it says round the slope to 2 decimal places and the y-intercept to the nearest whole unit. Because I made that mistake last class. Okay, so here's what we're going to do. We're going to go to our list. How do I get to my list? Stat edit. Good. Stat edit. Oh crap, I got crap in there. How do I clear it? Very good. Just think, Christian, if you were just here at all times. Giving you more time. Okay. Now, so we got L1 and L2 cleared out. Now let's start entering our stuff. So let's go 1007, 1003, 1000, 994, 983, 968, 950, 930, and 905. Happen to be 9 things again. I'm going to show you, I'm going to make a mistake on mine. But this is 35, 45, 50, 65, 80, 100, 110, 145, and then 160, right? Okay, the only thing I would suggest to you is when you're working on your homework or you're working on your tasks, I go through them pretty quick, right? I don't do this all the time. You'll get faster with it too. And we're all here checking each other. But when you're at home, nobody's checking you, so I would just, if you make a mistake, you get more than one chance at one problem, right? You get another chance to answer it. First thing you do, go back to your list to make sure the numbers match up. But watch what happens when I do this. Okay. You see my list? I've got more things under L1 than I have under L2. Watch what's going to happen when I go to calculate. I don't know why I did it like that. Uh-oh. I get an error message. Okay. I have two choices. There's dimension mismatch. That means my L1 and my L2 aren't matching. Okay, I got a mismatch there. So instead of quitting and hitting clear, I'm going to hit 2 to go to my mistake. So if I go to my mistake, and it doesn't really well, it blinks on L2. So that tells me something's wrong in there, but it won't go to my list. So I go to list, stat 1, and I go, oh crap, I got an extra number down here. But I'm telling you, it's going to happen. So I'm going to hit the, hopefully that'll do that trick. I don't know. Maybe. Sometimes it fixes it, sometimes it doesn't. I'll find out now. Go to stat, calculate 4. Ah, it gave me the answer. Okay. Be careful, because this means y equals, my slope needs to be 2 decimal places, which is negative 1.22 times x. And my y-intercept needs to be to the nearest whole unit. It's positive, so it's a plus sign, 1,273. Okay? Okay. Any questions on that? That is it for today. So I guess we will see you guys on